year 2000 and it's ending in the year 2010. That is my domain. Domain is where T, in the number of years since 2000. So that means 2000 is 0. So that's 0 to 10. Doesn't make any sense to graph anything outside of that because we're not going above 10 years before 2000 and we're not going below 10 years before 2000 because that would be negative and we don't go back in time. So the function's domain is going to be 0 is less than x, which is less, or t, which is less than 10. That is our domain. I will write that down. Just 1 second. Miss Blank has to get it together. So part A says state the domain. So my domain is 0 is less than or equal to t, which is less than or equal to 10. That is my domain. Then I'm going to graph it and identify and interpret the zeros. Again, we're talking about annual profit in years. So if we're talking about an intercept, the zeros, where is it at 0? Well, this is where y is 0. That's when there was 0 profit. So we're looking at x-intercepts. We're looking at where did they make no money in that year. So let's see if my calculator's still working. Woohoo! Tab. I'm going to enter in my new equation. So we have the, that's not what I wanted. One over 63 parenthesis x plus 2, nope, parenthesis x minus 1, parenthesis x minus 7, parenthesis x minus 9. Okay, I'm going to hit enter, but I'm still going to mess with my window anyways. I want my window to start at about a -2, and I probably want it to go to 12 because I need it to go past the 10 so I can really look at things. Okay, so here we go. From 0 to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm here. Okay, 10. What do my x-intercepts mean? So it looks like their profit has gone from no profit. They were actually owing money. After a year, they made 0 profit. So they've improved and they're breaking even. So then we're making some money and then we're losing some money. And right here, we're breaking even again. Then we've actually started losing money. We've turned it around and now we're broke even again and we're going up. So it's where we're breaking even. Where are we breaking even at? 1, 2, 3, 4, 5, 6, 7, and 9. 1, 7, 9. Okay? 1, 7, and 9. This one over here does not matter. We do not care. It's in the negative realm, and we're just looking between the numbers 0 and 10. And if you can tell, that's the 1, the 7, and the 9. And that's what it means. The graph of the function shows V in million dollars of stock portfolio over time in months. Guys, they're giving you the graph. All they're going to do is ask you, for what values of t is the function increasing? When are we going uphill? So that's from 0 until we hit this peak right here, which looks like 3. So from 0 to 3, we're increasing. Then we go downhill. And then right about here, so let's say 13 to 18, it's increasing. So for what values of t is the function increasing? For what values of t is the function decreasing? So we were going up, then down, then up. So we have 2 periods of increasing, 1 of decreasing from 3 to 13 months. And that's what you've got. Okay? That's my guess. Interpret the intervals found in part A in terms of the situation. So we're talking about a stock portfolio and valuation, right? It's the value. So the periods of increasing is when the value is going up, and the decreasing is the values when it's going down. That's really not difficult. Identify the coordinates of any local maximums and local minimums. Approximate the t values to the nearest half month and the v values to the nearest 0.25 millions of dollars. So identify. So I'm going to draw a dot right here. That looks like it is, I mean, if you really want to get technical, probably 3.5 months. I would call that a maximum. It's a peak. And it peaked somewhere between 2, 3, that's a quarter. I'd say 3/8, so 2 3/8 millions of dollars. So 2 3/8 millions of dollars. So it had a local maximum in 3.5 months where it was worth 2 3/8 million dollars. The minimum is sitting over here. I'd still say it's at 13 months, and its all-time low point was at $750,000. So $750,000 was its low point. That's an interpretation. Explain the significance of any local maximum and mins found in Part C. So again, we're going into high points and low points of the stock, although after 18 months, that really is the highest point out of the 18 months. So you just come on and talk to me about that. What is the fact that the function is always positive indicate about the appropriateness of this model? Well, we're talking about the value of stocks. Can stocks have a negative value? The answer is really no. They can have zero value. They don't have a negative value, so it wouldn't make sense for us to see negative numbers in this space at all. Okay, the quartic function just means it's to the power of 4. Models the average monthly high temperature in degrees Fahrenheit of a city T months after January. Using a graphing utility, graph the function, sketch the graph on the coordinate plane below, describe the function's end behavior on the graph. Does the end behavior make sense? What is a reasonable domain for this function? So if we're talking about T months after January 1st, I want to address domain first. The domain of my function should not go above 12 because otherwise we're back to January 1st, right? So 1 month would be February, or February 1st, and then January 1st, or March 1st. We can go around. There's 12 months in a year. I would say my domain shouldn't go past 12. So let's see if I can scoot that up at all. Nope, because we're at the bottom. Okay, I'm going to type this one in, and let's take a look. Can you guys see all that? Okay. Delete, 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 delete. Let's see if my phone or my calculator dies first. 0.04x raised to the 4th power. Oh, I put a 1 in there, guys. Why did nobody tell me? Minus 1.16x raised to the 3rd power. Plus 9.93 x squared. So I'm just trying to look around my calculator. Minus 22.19x plus 50.32. Enter. My graph might not necessarily be what I want it to be. I can't see anything. Because we're degrees in Fahrenheit, then we probably don't go below 20. So I'm going to go to my window. I'm going to set my window settings. And I'm going to leave the months by themselves, but honestly, like, we probably need to be going to 120 and counting by 5s. So that's what I'm going to do. Aha, magical. So here we go. We're going from 0. We're going to 12. We're going to take a look at the end behaviors. So as my time approaches 0, what is the graph approaching? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. I would say that we're dealing with 50 degrees Celsius. If we go to menu, analyze graph. I don't know if we can trace on this one. I have not been able to figure out how to do that. Oh, never mind. Trace the graph. So we can look at the coordinates down there. So we're looking for where does it cross this. Miss Blank went too far, guys. Okay. my y-intercept, where my time is 0, our temperature is 50.3. So January 1st is 50.3 degrees. As we go on, we're tracing. It dips down into the 30s. That was pretty cold. We keep going. We keep going. Remember, our domain is not all real numbers. Our domain ended at 12. So we want to figure out what happens as we approach 12. We've passed 12. Let's go back. So 12 is at 38.9. So we talk about the end of our domain. We're approaching 38, 39 roughly, if that's what you want to talk about. So we looked at our graph. You can sketch it on here. That won't be a problem. Describe the end behaviors. We talked about that. Does the end behavior make sense in this context? Sure does. We've always kept kind of within the Fahrenheit ranges of freezing or not freezing. Okay, in December it gets cold again. That's pretty normal. I really want to live in the city because it looked like their high was like ridiculous. Can I live in a city where the high like gets near 80 but doesn't quite touch it? Like, that is nonsense, guys. But it makes sense for any place not in Texas. And that is how you do the last bonus problem. So your test is the exact same questions with different numbers. You will have 10 multiple choice questions. You will have 2 graphing free responses, guys. And look, those were so easy. You type it in your calculator, you find your x-intercepts to plot, and then you try to just make it look like it. We're not artists here. We make no judgments. On this one, you need to sketch it, so you need to know your x-intercepts. But if you look at the directions, it's going to ask you to describe the end behavior. That is where you are going to write things like, as x approaches negative infinity, p of x approaches something. As x approaches positive infinity, p of x approaches something. So your 2 choices here are negative infinity or positive infinity. You're going to have to pick one when you answer, if you answer this bonus question. That is all you are doing. Good luck, guys. Oh, let's go back to number 2 because Miss Blank knows what she did wrong. So we couldn't really get an answer to number 2 because Miss Blank did not type things into her calculator correctly. So I am going to go in here and I'm going to start a new document because all of this craziness that we've just done in there is nonsense. Okay, so I'm going to add a graph and I'm going to type this one in correctly this time. So we did x raised to the cubic power minus 5x squared plus 2x plus 2. And we're going, oop, that's not 2. And we're going to graph it. Okay, here is our function. Now, let's take a look at graphing A again. X raised to the cubic power minus 5x squared plus 2x plus 6. That's not a 6. Enter. All right. So we're talking about having fewer and what is the profit. So we're looking at, here's a space of 1, 2, 3, 4 fewer bicycles. I still don't think that this is really accurate for what we're wanting to do. So if we take a look at option B, that is x cubed plus 7x squared plus 10x minus 6. Okay, so do you guys see how my little humps over here went from -1 to +1? And now my little humps are at -1, 2, 3, 4, 5. -5 and -3. So this point jumped 1, 2, 3, about 4 over. And this one jumped 1, 2, 3, 4 over. So my critical points here have all moved. This one, which is in this little weird space here, jumped 1, 2, 3, 4. They've shifted to the